How to sort a map key value by values in Java. Introduction. Maps are one of the most commonly used data structures in Java. A map stores data as key means value. Examples. Tick, student means marks. Product means price. User means score. Country means population. A very common Java question is, how do you sort a map by its values? Example. Apple, 50. Orange, 20. Mango, 80. Sorted by values. Orange, 20. Apple, 50. Mango, 80. This topic helps learners understand how maps work, why maps are not automatically value sorted, sorting using collections, sorting using streams, LinkedHashMap comparators, ascending and descending order, best practices. This is an important Java collections topic. Important concept about map ordering. A normal hash map. Hash map does not maintain order. Example concept. Insertion order means not guaranteed. Sorted order means not guaranteed. Why sorting by value is special. Java provides check sorting by keys using tree map. But no, there is no direct value sorted map implementation. So developers usually convert entries to a list, sort entries, rebuild ordered map. Example map. String integer scores equals new hash map. Scores put John 80. Scores put Alice 95. Scores put Bob 70. Approach 1. Using list plus collection sort. This is the traditional approach. Step 1. Convert map to list. List map entry string integer. List equals new array list of scores.entry set. Step 2. Sort list. List.sort map entry.comparing by value. Step 3. Print sorted values. For map entry string integer entry, printing logic goes here. System.out.println entry.getKey plus dash plus entry.getValue. Output. Bob 70. John 80. Alice 95. Full example, import java.util. Public class main. Public static void main. String args. Map string integer scores equals new hash map. Scores.put John 80. Scores.put Alice 95. Scores.put Bob 70. List map entry string integer list equals new array list scores.entry set. List sort map.entry.comparing by value. 4. Map.entry string integer entry in list system out println entry.getKey plus entry.getValue. Example concept. Map dash entry list dash sort entries ordered result sorting in descending order. Use collections dot reverse order. Example. List dot sort map dot entry comparing by value collections dot reverse order. Output. Alice 95. John 80. Bob 70. Approach 2. Using Java streams. Modern. Java 8 introduced streams. This is now very common. Stream sorting example map. String integer sorted map is scores.entryset.stream. Sorted map entry.comparing by value. .collect. LinkedHashMap new. Map entry get key entry get value. LinkedHashMap put all. Because LinkedHashMap preserves insertion order. After sorting, key insertion order equals sorted order. Output example. Bob equals 70. John equals 80. Alice equals 95. Stream sorting in descending order. Example. Sorted. Map entry.comparing by value. Collections.reverse order. Sorting by keys versus values. Sorting by keys. Easy with. Tree map. Example map. String integer. Sorted equals new tree map. Scores. Sorts by keys automatically. Sorting by values requires check manual sorting logic because maps are not value indexed. Real-world example product prices. Map string double prices equals new hash map. Prices.put laptop 1200.0, prices.put mouse 25.0, prices.put monitor 300.0. Sorted by price. Mouse, monitor, laptop. Very common in e-commerce systems. Sorting custom objects by values. Example: map, string, employee. Use custom comparator. Example list.sort. Comparator.comparing. Entry.getValue.getSalary. Very common in enterprise applications. Common errors 1. Expecting HashMap to stay sorted. Wrong assumption. HashMap maintains sorted order. False. 2. Forgetting LinkedHashMap. Without LinkedHashMap, sorted order may be lost. 3. Sorting original map directly. Maps themselves are not directly sortable by values. Need, entries, streams, lists. 4. Null values. Example: map entry comparing by value may fail if values are null. Use null-safe comparators when necessary. Null-safe comparator example: comparator.nullsLast, comparator.natural order. Performance considerations. Sorting complexity. O of n, log n, because sorting algorithms are used internally. For very large maps, sorting can become expensive. Best practices. Best practices include: use streams in modern Java. Use linked HashMap after sorting. Use comparators for custom sorting. Handle null values safely. Avoid assuming HashMap order. Example concept: sorted entries means predictable output. Advantages of stream approach: concise, modern, readable, functional style. Advantages of traditional list approach: check. Easier for beginners. More explicit. Compatible with older Java versions. Limitations: sorting creates additional collections. No built-in value sorted map. Large maps may affect performance. Concepts learned in this topic: map sorting, map entry, comparing by value, linked HashMap, streams API, ascending and descending sorting, comparator usage, value-based ordering. Simple definition: sorting a map by values. The process of ordering map entries based on their values instead of their keys. Final summary: Java maps cannot directly sort by values. The common solution is: convert entries to a list, new array list, map.entrySet, sort entries map.entry.comparing by value, store in linked HashMap. Modern Java commonly uses streams. Stream.sorted.collect. Key idea: Java maps are key-based structures, so sorting by values requires manual entry sorting. Once you understand map sorting, working with collections becomes much more powerful and flexible.